Okay, so in Unit 1 we deal with primarily Chapter 2. Chapter 1 is on your own, okay? And Chapter 2 is about the methods of science. So that's what this lecture is going to be about. So this is the first of various lectures on this topic. So the first thing when we're dealing with the methods of science is trying to understand what does that mean. And the methods of science are just ways of doing research. So science is one way of knowing things, and if you're going to use science, you have to use one of their methods, and those methods have various rules and requirements and so forth. So the goals of any science, including psychology, are to describe, explain, predict, and control. So we want to describe whatever it is we're interested in, we want to explain it, and hopefully be able to control it and predict when it will happen and so forth. So let's say I'm a psychologist, let's say I'm interested in depression. I would want to be able to describe depression, meaning just saying what depression is. So for example, what are the symptoms of depression? How do they differ from grief? So grief is not depression, right? How do we tell the difference in depression amongst infants, children, adolescents, adults, and the elderly? What are the symptoms and how are they different in those different cases and so forth? So this would be just describing depression only. And then explaining is being able to determine how does depression happen and why does it happen. Basically being able to explain a cause or an effect. Okay, this is the cause of depression. And then predicting would be being able to say these people are more likely to get depression. These things that happen to you are more likely to lead you to develop depression. These are some things that make it more likely for you to recover from depression and so forth. And then we use all of that to be able to control. Now the problem is that science has certain assumptions that it makes, and it knows it's not perfect. So what it does is it's constantly testing itself, right? But it also has certain rules that you have to follow. For example, if I can explain and predict, basically that means I've described, right? And if I can explain it, I can probably predict it. So there's only one method of science, which is an experiment, which we'll talk about another time, that actually accomplishes all four goals of science. So why would we do something else other than an experiment if an experiment gives us the most amount of information? Well, the reason is because there are requirements to doing an experiment. You have certain things you have to do it this way. And if you can't, for some reason, do it that way, then you can't use an experiment. Okay? So there are these methods of science, there are four of them that we're going to talk about, that are called descriptive methods. And they're called descriptive methods because when you use that method, the only thing you can do is accomplish this first goal of science, to describe. So these are called the descriptive methods of science. Now, some methods in science have more rigor than others. Rigor means strength. And strength means that we are more confident of our results. The stronger a research method is, the more confident we can become in our results. So experiments are very rigorous, and therefore we have much confidence in our results. But descriptive methods have very little rigor, so we are not as confident in our results. And as a result, we cannot lead to certain conclusions. So I can only conclude, here is what I saw, or how much, what I got there. I can't say this is how or why it happens, or this is when it will happen, and so forth, if I use one of these descriptive methods. So we're going to talk about each of these descriptive methods today at length, which are laboratory observation and naturalistic observation, survey, and case study. Okay? But before we go through each of these and explain how we do them and what their strengths and limits are, we are going to discuss some terminology that's used in research, okay? Some very basic terminology. So the words are population, sample, and subject. So the entire group of people that I'm interested in, everybody that I'm interested in, is a population, okay? That's the population. A sample is the group from within the population that's actually going to participate in my study. And the individuals within that sample are subjects, if they are people or animals. Obviously, if it's a cell or something like that, it could be a specimen or something like that, okay? Now, what this means is that when we do any kind of study, we usually can't test it on an entire population. So if I want to see if this new medicine is good for depression, then what I'm going to do is I'm not going to give it to every human alive who has depression because I don't have access to those people. And some people don't know they're depressed, right? So how would I know if they are? And they're all over the world, and they're all kinds of ages and so forth. So what I'm going to do instead is take a sample of people, a group that all have depression, and give them this medicine to see if they get better. And then what I'm going to do with that is I'm going to generalize from the sample to the population. Generalizability means that what's true of the sample is true of the population. So science allows me to assume that if the medicine worked for the sample, it's likely to work for the population. Science allows me to assume that whatever I find to be true for the sample is likely to be true of the population. Now we know that we don't always have generalizability. In other words, that we can say what's true of the sample is true of the population. So sometimes we lack generalizability, or we fear that we might lack generalizability. And when that's the case, there are certain things we can do to make sure that our results are true and not lacking in generalizability. Okay? So we're going to talk about some of those, a little bit today, but mostly in the next lecture. Okay, so how do I get generalizability? How do I get some assurance that what's true of my sample is true of the population? Well, one of the most important aspects of this is getting what we call a representative sample. A representative sample is a sample that represents the population well, because important subgroups in the population are reflected in the sample proportionately. So for example, let's say that I wanted to do a study on American armed forces, on the people in the armed forces, okay? And I get a sample, and this sample is 50% male and 50% female. Is that a representative sample of the population? First, tell me, who's my population?
The military.
Who?
The military.
Yeah, the people in the armed forces. So that's my population, okay? And so I'm going to get a sample. The sample I got is 50 male, 50 female %, okay? So is that a representative sample?
No.
Huh?
No.
No, why not?
There aren't 50% of the military's females.
Right. So then the military is not 50-50. We all know that, right? There are many more men than women in the military. Therefore, if I get a sample that's 50% female and 50% male, that's not what the population looks like. I'm guessing 80-20 or something like that, right? 80% male, 20% female, maybe, okay? Or maybe not even that much, but anyway. So I'm over-representing females because they only should be about 20% of my sample. And I'm under-representing males because they should be about 80%, and here they are only 50. And this is for anything. Like, let's say I know that my population is 10% Hispanic. Okay? I want my sample to be approximately 10% Hispanic. So, not 1% Hispanic, but also not 20% Hispanic. Right? I want my sample to look like the population if I know what the population looks like. However, sometimes we're studying something and we don't know what the population looks like. So we're studying depression. The first times we study this, we don't know that depression happens more often in in females than males. We don't know this, right? So at times we're working with a population, we don't even know if the sample is representative because we don't know the population very well. So, how do we get a representative sample? The things that are more likely to lead to a representative sample are getting large or random samples. Large random samples are more likely to be representative. So listen to me, this is important. What we want, what we're shooting for, is a representative sample. Getting a large sample or a random sample is just a way of making it more likely that our sample is, in fact, what we want, representative. Okay? Now, let me show you how the large thing might work. Let's say you guys are my population. Okay? I don't know y'all. We don't see an entire population. We don't see, if I want to see depressed people, I don't see every depressed person in the world, right? Okay, so you guys are my population, and I don't know you. But I pick a sample. Let's say I pick that row, a small sample of y'all. And so I start to learn about y'all by studying these 3 people. Well, these 3 people happen to be female. So I might come to the conclusion that the whole class is female, right? Because my sample is smaller. But what if I make my sample a little bigger, and now I don't have 1 row, but 2 rows. Now I have some males. You see what happened? So the larger my sample got, the closer it got to looking like the population. So larger samples represent the population better, typically. So what about random samples? Well, a random sample means that, like, let's say I get, dice, right, that you roll. I get 1, which is called a die. So I get a die, and I give it to each of you to roll. And I say, everybody who rolled a 1 is going to be in my sample. Okay? Now, if you roll something, it means nothing to what she's going to roll, right? So you can roll a 1, and she can roll a 1. But if you roll a 2, she might roll a 7. Well, not a 7, a 6. But you see what I'm saying? So basically what's going to happen is that what one person roll has nothing to do with what the next person roll. So you have a 1 in 6 chance of getting in my sample, and so does she. Not at all affected by you, right? Okay, that's random. But random is very, very hard to do in real life. How do you get a random sample of Houstonians? That is not easy. We don't all have addresses. We don't all have emails. We don't all have phone numbers. We don't all shop at the same grocery store. We don't all live in this side of town or the other, right? So it's very, very difficult to do. How about a random sample of HCC students? Can I do that? Sure.
Yes.
Much easier because it's a limited population, right? And think about how much more I know about HCC students than I know about Houston in general, every Houstonian, right? I know your address, I know your phone number, I know your email, I know where you are at 11 o'clock on Tuesdays and Thursdays. So I literally know a lot about you. So it's much easier for me to do a random sample from such a limited population, okay? So that some populations are not very conducive to a random sample and others are. All right, so we are going to come back to the concept of generalizability and come back to the concepts of samples a little bit too. All right, so now we're going to start with the 4 descriptive methods of science. The first one is naturalistic observation. And remember, what these 4 have in common is that because they are descriptive methods, what that means is that you don't have a lot of control or rigor. And as a result, when you come to a conclusion after doing one of these studies, your conclusion can only describe what you saw or measured or whatever. You can't say this is why or how or this causes that or when. You can't do any of that. All right, so naturalistic observation means that you observe people or animals or whatever you're observing without interfering in what you are observing. Usually it's in the natural environment because if you're not going to interfere, you got to go where it happens, right? So if you want to see kids, you might go to a playground because that's where kids happen. If you want to see teenagers, you go to a mall because that's where kids happen. Teenagers happen. And if you want to go, I'm a little confused there. And then if you go want to see monkeys, you might go to the jungle because that's where jungle. Ah, damn it! Again, that's where monkeys happen. Okay, I'm getting ahead of myself. All right, so we're not going to interfere. And the good news about this, the stuff that it can do that's kind of unique and good and powerful, is that it gives us natural information about how things naturally occur, spontaneously. And sometimes it might be the only method available, so we have to use it. It also gives us hypotheses, which are predictable, testable, predictions, okay? So we can test a prediction that we make from watching, okay? Now let's talk about the only method available. Let's say you're trying to watch some sort of animal, like whatever species, and that animal doesn't want to mate in captivity. So in order to learn about the mating patterns of that animal, you have to go out in the natural environment and watch them. However, this can happen, you can do that, but you're likely to have some problems. First of all, you have no control over the situation. So they just put in some Luther Vandross and they're getting ready to do their mating thing, and all of a sudden, here comes a predator. And there goes the lovemaking, and now let's talk about survival, right? Do we fight or flee or whatever, or freeze? So being observed can also change behavior. The animals know you're there, or people who know you're there are not going to behave the same possibly as if you were not there. Therefore, these observations have to be done somehow in secret with a hidden camera or a two-way mirror or something like that. So there are problems with naturalistic observation. Now, when you hear the term bias, in research this means error. And observer bias is an error that occurs because the observer makes a mistake. You miscount something, or you misunderstand what you're seeing. You think that was aggression, and really it was play. You see, you didn't quite understand it. This is why when we do this kind of research, the observers are usually more than one. Everybody sees things from their own perspective, right? You never see anything outside of your head. Your eyes are in your head, and every time you go to see something, there it is through your head, right? So what happens is we have to try to get the observers to be numerous, and also we train them. Okay, this is what we're going to consider aggression. If the behavior is like this and this and this, and if it doesn't have these things, then it's play. You see what I mean? Okay? So we're going to train them, and we're going to make sure they're on the right track, and we're going to have multiple observers doing that. So we're going to hide, of course, and then observer bias is going to be controlled, hopefully, with our training and our multiple observers, but it can always potentially be a problem. So observer bias happens anytime you're observing, which means it can happen in naturalistic observation and also in lab. Make sure you know that. Observer bias happens anytime you're observing. So it can happen in naturalistic observation, and in a moment we'll see it can also happen in lab observation. Okay, so some examples of observation. Let's say I want to find out how 4-year-olds resolve conflict, okay? So I go to a daycare and I say, hey, I want to observe your kiddos and I want to see how they do when they are dealing with conflict. Now, if it's naturalistic observation, that means I make no interruption whatsoever. So I can place some hidden cameras, and I don't change anything. I let the kids come in to the regular playroom, and whatever happens, happens. Okay? And after hours and hours of watching tape, that somebody has to pay for, my time or whatever, then I will see that conflict didn't arise that often. I thought it would be more often, but it didn't arise as often as I thought. So I got lots and lots of hours of tape and only a few incidents of conflict, which is what I wanted, right? And then I noticed that on all of these incidents of conflict, every time that the two kids start to have a conflict, somebody breaks it up. Here comes the teacher or the aide and tells them, okay, no, no. So that's not what I want. I mean, granted, let's go back. Is it good information? Yeah. It's telling me how things naturally occur. But the problem is it's not telling me what I really want. which is how do the 4-year-olds resolve the conflict themselves. So instead, I might do a laboratory observation. A laboratory observation means that I am going to watch, not in a laboratory, but I'm going to contrive a situation. I'm going to set it up, okay? So for example, I might say, okay, I'm going to tell these aides not to interfere. Teachers and aides, unless you see blood, just let these kids handle the conflict on their own, okay? And then I'm going to say, hey, how can I make it happen more often? Okay, what if I get a playroom and I put 2 toys in there and I only bring in 3 kids at a time? Is that natural? Is that how things naturally occur?
No.
No, naturally it's a big room, lots of kids, all kinds of toys, right? But I'm setting up this little room where there's 3 kids and 2 toys, okay? So I've set up a situation that I think will let me see what I want to see. But that also presents a problem. So I have more control, and I can control for interferences and say, don't do that, or whatever. However, I have still the potential to make a mistake in what I see, right? To misunderstand or miscount. I still have to make sure they don't know I'm there, or their behavior will change. And now I have an additional problem, okay? Now notice something. I got a little bit more rigor, and with more rigor comes more potential problems. So you'll see that throughout this unit. You'll see that as I teach you about the methods of science, when I teach you about experiments, we're going to talk about 5 potential problems in an experiment. Okay? So naturalistic observation, observer bias can be a problem in naturalistic and lab. And now we have this new kind of problem called situational bias. So bias means error, and this is an error that occurs in your results. And it occurs because of the way you set the situation up. In other words, if you would have set the situation up differently, you would not have come to that conclusion. Okay? So, for example, let's say I put the 3 kids in there with a couple of Nerf guns, or a couple of Nerf swords, or 2 games, Candyland and Chutes and Ladders, or 2 balls, 3 kids. Okay? You with me? You got everybody with me, right? So all these different scenarios. Am I going to get a different conclusion? Probably. If I put in 2 games, they all might decide, okay, let's play Candyland. And there's no conflict. However, if I put in the swords or the Nerf guns, they might be beating up on the poor kid that didn't get one, right? So the result I got may not be due to just how kids naturally are, but to what I did, how I set that situation up. Okay? So this situational bias means a bias or error that occurs in the results as a result of how I set the situation up. And this only occurs in laboratory observation. Make sure you know that, and make sure you feel very comfortable with situational bias because it's not in your textbook. Okay? So observer bias means that you make an error in your observations, and situational bias means that the way you set the situation up led to a particular outcome, and it would have been different if the situation would have been different. Okay? Yeah.
We're gonna get a video with the phone nothing for the next one.
I'll put them up here. Okay, so the question was, can he get a copy of the video? The answer is it will be up on your classes as well as online. Okay? All right, so situational bias only goes with laboratory observation. You must know that. Situational bias, only lab. It's the only time we call it that. So let me give you another example that's something you could relate to a little better regarding laboratory observation. Let's say I wanted to know who's more helpful, men or women, in college. And I might want to know, well, as we talk about it, you're like, well, I don't know. I think men might be more helpful, but only towards other women and not towards other men, right? Well, we could set a situation up like that, couldn't we? Maybe in the hall, I could have somebody drop their books and see who comes to help them, right? And I might want to, sometimes it'll be a woman that drops the books, and let's see who helps her. And sometimes it'll be a man, right, who drops the books, and see who helps him. You with? So that's an example of naturalistic observation that I'm sure you can imagine us doing here in college. Okay? All right. Any questions about these two? Now remember, both of these can also lack generalizability, because if we got a sample that doesn't look like the population, then the result we got for the sample is not going to apply to the population. The next thing we're going to talk about is surveys, which I know all of you have participated in. A survey is a way of asking people questions, and it can be done with a questionnaire or an interview. And of course, it can be done in many, many different ways, using email, phone, in person, all kinds of stuff. Also, it can be open-ended questions, like how much is your family income, or closed-ended. In which of these ranges does your family income fit, right? So it can be just A, B, C, or D, or yes or no, which is closed-ended, or open-ended, where you allow the person to tell you. Okay. So the strengths of a survey is that it's a great way to get information from a large group of people in a relatively short period of time, and it's also not very expensive. Okay, so it's a great way to get information about how often. So for example, how often do people think this, believe that, have had this happen to them? How often do people go